Hi, welcome to another episode of Out of the Blue. I'm Blue, and today we're going to be talking about different sizes of infinity. Now, if you've seen or read The Fault in Our Stars, you've heard Hazel Grace talk about how some infinities are bigger than others. Real quick shout out to John Green, he's a great author, and if you're a nerd fighter, hello, I am too. Hazel Grace in this book and movie talks about the different sizes of infinity, how some infinities are bigger than others. And while you can just think of it like, wow, that sounds really pretty, that's so beautiful, they have their own little infinity, that's so sweet, you can also actually think about it mathematically and think that's kind of weird. It kind of seems odd that something can be bigger than infinity, or that some infinity can be somehow smaller than another infinity. It's kind of odd. Infinity is kind of hard to think about in the first place because something infinite is something that just goes on forever and ever and ever. So an infinite set just goes on forever and ever and ever. It's why you can't think of the largest integer, because I could give you some ridiculous integer and you could just add 1 and that number you give me back is going to be bigger than mine, therefore there are an infinite amount of integers, 1, 2, 3, 4, you know what I mean. So in math, we use a lot of times sets to talk about things. So we can have a set of, for example, all of the integers, 0, 1, 2, all of the integers are a set. It's obviously an infinite set. We can also have a set of smaller things. So we can have a set of, cats or dogs, and that'd be finite, unfortunately. Cardinality is the number of things in a set. So the cardinality of the set of 1, 2, 3 is just 3. The cardinality of the set of dogs I own is also 3 because I have 3 dogs. Cardinality is just the number of things in a set. Where it gets cool, where it gets tricky, is when we talk about infinite sets like we were talking about before. So what I mentioned was the set of all integers. I'm going to reduce that to the set of natural numbers. What's a natural number? A natural number is a counting number. A counting number is 1, 2, 3, 4, extended all the way into infinity. Now, as you can tell, there are an infinite amount of these. Like I said, just add 1 and then you get a bigger one. There are an infinite amount of counting natural numbers. It turns out this set of counting numbers is actually the smallest infinite set possible. And that seems kind of weird because, the smallest infinity? It's still infinite. Obviously, there's nothing bigger, right? But no, a lot of things are bigger because some infinities are bigger than others. The set of natural numbers happens to be the smallest infinity possible. Because of that, we refer to sets that have the same cardinality as the natural numbers as countably infinite. Let's say I wanted to take all of the numbers divisible by 3, right? So all of the positive numbers divisible by 3. Then I could just say, well, we will make each one correspond to the number by which it is divisible by 3. So let's say 3, well, that's going to be 1 because 3 times 1 is 3. Let's make 6 be 2 because 3 times 2 is 6. 9 will be 3 because 3 times 3 is 9. And every single number divisible by 3 is going to correspond to the number that it takes to multiply by 3 to it. So there are as many numbers divisible by 3 as there are numbers total. Just total, because each one corresponds to a number. Now that might not make sense because you say, well, only every third number is divisible by 3, but because infinity is just kind of weird and funky like that, you can do that because you can prescribe each one a counting number. That way that set is countably infinite. So how does a set become non-countably infinite? Because it seems like no matter what set you have, you can just find a funky way to connect it to the counting numbers, right? Well, that's not quite true. Let's just say I want to take the set of all numbers between 0 and 1. Okay, so let's say we start at 0, right? 0 is our first number in the set. Well, our second number, is it going to be 0.1? So let's say our second number is 0.1. Well, what about all the numbers between 0 and 0.1? 0.01, 0.02, 0.03, 0.001. All of those numbers, we haven't prescribed a number that is countable. We haven't given it a 1, 2, 3 sort of coordinate system because we can't, because there's no way that we can go all the way down through the decimals and prescribe each one in between a number. So in that way, there are more numbers between 0 and 1 than there are integers total. I mean, the infinity between 0 and 1 is absolutely bigger than the infinity of all counting numbers. I think that's kind of mind-blowing and weird and cool, and Maybe it's just me that thinks it's cool, but it is really neat. I think that's really cool. That's the way that some infinities are bigger than others. You can take this philosophically if you want. You can think of, whatever time you spend here as your own little infinity. You can think of love and passion and all this stuff as your own little infinity if that's how you want to take it. Take it poetically, take it mathematically, however you think about it. I'm just glad that you're thinking about it now. And I will see you next week to talk about some more math or science or really anything you feel like talking about. I felt like talking about infinities this week, so that's what happened. But if you want to ask for anything to talk about, just send that to me and I'll get it to you, and I'll see you next week.